Lesson 23 is on models of electromagnetic radiation. And basically, we have two models of what is electromagnetic radiation. Is it a particle or is it a wave? And early scientists, such as Sir Isaac Newton, believed it was a particle. Why did he believe it was a particle? Because of these things. Because light travels in straight lines, because light can be reflected, and light can travel through a vacuum. And all those things particles can do. So he was pretty convinced that light was a particle. Then a later group of scientists started to think as light as being a wave. Why did they think light was a wave? Well, we have this guy, Christian Huygens, and he did a whole bunch of interesting experiments, and he found out that light could diffract, which particles don't do. Diffract, if you recall from physics 20, is when something bends around an object, like a water wave. If you have a water wave and it goes through a slit, it will bend around that slit in this way. Let's try and represent that. There's my... So I have a slit here, and then I have this water wave. Oh, I should have done the water wave in blue. Here's the water wave. And that water wave is moving this way, and it hits this slit. Well, this part of the wave will just rebound and go this way, but this part of the wave here will go through the hole. Let's change it to green. So this part of the wave will go through the hole, and what will it do when it gets through the hole? It won't just keep going like that in a straight line. It will bend around this opening. So the water wave will eventually look like this. Okay, so that's diffraction. So if light diffracts, then it's exhibiting wave properties. So that's what Mr. Huygens did, and he also found that light waves seem to also reflect and transmit. And as you can see in this example right here, you can see that an incident wave hits this boundary. Some of it reflects, angle of incidence equals the angle of reflection. We'll talk about it in a later lesson. But some of it also transmits, and as you can see, it's not going in a straight line through here. It's actually bending, which is called refraction. Again, we'll talk about that in later lessons. And particles don't do that. Particles don't reflect and refract at the same time, whereas light waves do, or waves do. So that was another reason that he thought light was a wave. And then comes this guy, Thomas Young, and in a later lesson, we're going to talk about this experiment in detail, but let me just highlight this or give you some background information for this experiment. I have a picture of it here. This is the famous Young double slit experiment, and in this example right here, you can see you're shooting particles through a double slit. There are two holes here, a hole here, and a hole here, and they go through, and you would expect on the screen that they form two bands. So if you have two holes and then you have a screen, you would expect that these particles would go through the holes and just all hit on the screen, and you would see a screen with two marks on it right there. So that's what happens with particles. But if you shine light through a double slit, that's not what happens. You don't get a slit. Here's your slits here, and then here's your screen here. You don't get just a band of light right here and a band of light right here. What you end up getting is a diffraction pattern or an interference pattern. So the light diffracts, and then, in other words, it bends around these slits, and then it interferes. These waves interfere with one another and produce an interference pattern. We'll talk more about that in lesson 30, but it's a really cool experiment that Thomas Young did to prove that light has lots of wave properties. So now we have a contradiction. We have some scientists saying it's a particle, some scientists saying it's a wave, electromagnetic radiation. What is the actual truth? The truth is we don't really know, but we do know, or we do think, that light has a wave-particle duality. In other words, sometimes it acts like a particle, sometimes it acts like a wave, depending on the situation. And as we progress through history, maybe this theory will change and we'll figure things out. But great thing about physics, it's always changing, and we can never say with certainty we know But now we come to this concept here. So we have this concept called black body radiation, which again we'll discuss in another lesson. And Max Planck was able to come up with a solution as long as he assumed that energy came in little pieces called quanta. So now we have this next group of physicists like Einstein. Einstein said that light comes in little pieces. And remember, whenever I say light now, we're talking about all forms of electromagnetic radiation, not just the ones that you can see. We're talking about radio waves, gamma rays, X-rays, ultraviolets, microwaves, and so on. Ooh, there's a science department meeting in 15 minutes. Okay, so light refers to all of them. So Einstein proposed that light comes in little packages or little pieces, and we call those photons, and that, again, points to light being a particle. So Einstein was back on the particle train. And that's kind of where it ends. We're kind of, at this point, we're saying that light has a wave-particle duality. It can be a wave, it can be a particle, depending on the situation, and they both work. Okay, so that are models of electromagnetic radiation. The next lesson is Maxwell's theory of electromagnetic radiation, coming right up.